Hello everyone. Let's begin with a simple but fascinating question. When many particles move in different directions, how do we describe the motion of the whole system? The answer lies in the center of mass. Its position vector is given by R equals 1 over m times the summation of MIRI. If we differentiate this with respect to time, we get a beautiful result. M times V equals summation of MIVI. Equation 6.8 tells us that the velocity of the center of mass is just the mass-weighted average of particle velocities. So even if every particle wiggles differently inside a rocket or a gas cloud, the center of mass moves with a neat, predictable velocity. Now let's go one step deeper. Differentiate again, and we get the acceleration of the center of mass. M times A equals summation of MIAI, that's equation 6.9. Here A is the acceleration of the center of mass and AI are accelerations of individual particles. This means the overall acceleration is not random. It is simply the weighted average of all particle accelerations. That prepares the ground for connecting Newton's laws to systems, not just single particles.
Remember Newton's second law for a single particle. Force equals mass times acceleration. For particle I, we write Fi equals MIAI. Now, if we substitute this into equation 6.9, the result is m times A equals the summation of Fi. That's equation 6.10. Here capital M is the total mass, and capital A is the acceleration of the center of mass. But notice something subtle. Each Fi includes both external and internal forces. The internal forces always occur in action-reaction pairs, equal in magnitude and opposite in direction. When we sum them over the whole system, they cancel out perfectly. So, in the end, only the external forces survive in the equation. And that's a powerful simplification. It means that no matter how chaotic the internal forces are inside a body, atoms colliding, molecules vibrating, they do not affect the motion of the center of mass. Only the net external force decides its fate.
After accounting for cancellations, we arrive at the key result, MA equals F external. That's equation 6.11. It tells us that the center of mass moves as if the entire mass of the system were concentrated at that point and all external forces were applied right there. Whether it's a rigid body spinning or a cloud of gas molecules colliding internally, the center of mass obeys this simple law. It reduces the complexity of thousands of particles into one elegant motion. Here's a striking illustration. Imagine a projectile following its parabolic path. Midway, it explodes into fragments. Inside, huge internal forces rip it apart. But remember, internal forces cancel in the center of mass equation. The only external force is gravity, which remains unchanged. So what happens? The center of mass of all those fragments continues on the same parabolic path, exactly as if no explosion had occurred. You can see this in the figure. While the fragments scatter, the comb traces the same graceful parabola. Let's test the idea with a practical example. Suppose two blocks, 2 kilograms and 3 kilograms, are connected by a light spring and placed on a smooth horizontal surface. The spring pushes and pulls, but those are internal forces. Step 1. Internal forces cancel between the blocks. Step 2. Since there is no external force, F external equals 0. Applying equation 6.11, we get MA equals 0. Therefore, acceleration of the C dot O dot M is 0 and its velocity remains constant. The result? The system may jiggle, the spring may stretch and compress, but the center of mass glides smoothly with uniform motion. This law has far-reaching consequences. The translational motion of any system is fully described by the motion of its center of mass. Rotation, vibration, or internal collisions do not disturb the C dot O dot M path. This is why guns recoil when firing bullets, why rockets accelerate by ejecting fuel, and why explosions do not deflect the C.O.M trajectory. If external force is zero, the velocity of the C.O.M stays constant. That's the seed of the conservation of momentum principle, which we'll explore next.
So to wrap it all up, the velocity and acceleration of the center of mass come from simple weighted averages. Internal forces cancel out completely, leaving only external forces to govern COM motion. The golden equation ma equals F external makes every complex system behave like a single particle at its center of mass. From exploding projectiles to rocket launches, this law unifies countless real-world phenomena under one umbrella. I hope this gives you a solid and exciting understanding of how the center of mass moves. In the next session, we'll connect this to momentum conservation, one of the most fundamental principles of physics. See you there.